Alright guys, going to do a quick tutorial video on the relations and functions review packet. I'm going to show you real fast. So what we've got is we're going to do the mapping of this function, and it relates to domain and range and tells you whether or not it is a function or not. So the first numbers, the x coordinates in this case, and luckily for us they're all already in numeric order, least to greatest. Those are all of our inputs. So -2, 0, 1. Now since it's a repeated 1, we don't have to write it again. 2 and 3. So those are our inputs, which go in the first oval, which is our x values. The next one, 2, 5, 6, 7, -1, and 2 are our outputs. So, going least to greatest, we have -1, both 2's, so we only have to write it once, 5, 6, and 7. So -2 is assigned to the 2, 0 is assigned to the 5, 1 is assigned to the 6, 1 is also assigned to 7, 2 is assigned to -1, terrible arrow, I apologize about that, and 3 is assigned to 2. Now, how do we determine if it's a function? Well, we look for any arrows leaving the input. And if we have more than one, which we do right here at 1, then it is not a function, because each input has to have a unique output. Now domain gets really easy in this case. So all we have to do is make our curly bracket, which is an S followed by a 2, and then just write our inputs in numeric order, which we've already done. So -2, 0, 1, 2, and 3. And same thing for our range, except for our range, it's all of our output values. So, oh, not a parenthesis. Curly bracket. So that is how we do it if we're given a set of points. Now, what if we're given a graph? So if we're given a graph, in order to determine if it's a function or not, we need to take our vertical line, which I'm demonstrating with this purple line, and we need to run it back and forth across our graph. And if it hits more than once on either our image or on the points, which right there it does at -2, notice it runs through both of those points, then this fails as a function. It is not a function. So yes, that one fails as a function. Now for the domain, the easiest way to do this is to work from left to right and write down our values in order from left to right. So as we see the 2 points on the left hand side right here, what we need to realize is both of those have an x value of -2. So we're going to write that down. The next point, going from left to right, has an x value of 1, then 2, then 6. So for our range, we're now going to work from bottom to top. So our lowest value is a -5. Next is -1, followed by 2, and finally 3. Alright, for the next ones off of the initial one, so we've been tasked to find the range given the domain. So on this very first one, try to keep my calculator on the screen. On the very first one, we've got that our domain is -4, -1, 0, 3, and 5. So we're trying to find f of -4, f of -1, f of 0, f of 3, and f of 5. And notice they're inside of the parentheses, so they have replaced our x value. So the way this works is we have -4 times whatever we're substituting in, which in this case is -4 as well, plus 7. So substituting the value in, plug it into the calculator, we find that it's 23. And we do the same with the other values as well as we go through. And here's the quick shortcut on the calculator. Second, enter. And now I can just arrow back and change from -4 to -1. Find out that it's 11. Same thing for substituting 0, 7. Same thing for 3. And finally, same thing for 5. So going back over here, we know that it was 11, 7, -5, and -13. So our range would be these 5 numbers in numeric order. So -13, -5, 7, 11, and finally 23. Okay. And that's all we're doing for finding range. You substitute in the values of your domain, get your range, and we can move on. Alright, so next we are working with determining if our function is linear or not. The way we tell if it's linear or not is we look at these growth patterns and compare them to each other. So for each element going from an x value to the next x value, these all have the constant rate that we're adding 1. So this is going to make things much easier for us. Our y values, if we look on the first one, that's adding 3. That one's adding 3 as well. We've again added 3. And finally, one last time, we've added 3 again. So when we go through all of this, the change in our y is 3 on all of them. The change in our x is 1 on all of them. So we have the same constant rate each time. Therefore, since this rate is changing by the same thing each time, it is linear. Okay, guys, so look out for video number 2 where I'm going to do the other 4 examples, and good luck with your test.